back everybody. Part 13 here in our single-ended amplifier build. We're building this single-ended 807 amplifier. First and foremost, I want to apologize for my delay in this. I had some customer gear getting backed up that I needed to get to, and then the holidays kind of rolled around. I had kids home from college, so just didn't get a lot of videos cranked out, but I should be in a good place now with the customer gear and back at this series, so stay tuned. Alright, since my last video, I had someone reply to one of my videos and actually caught something that I didn't. This Mark Tollison here said, just noticed a problem with your BOM. The 100 watt, 1 watt Zener is underrated for the current it will be carrying, which is about 13 milliamps. So about 1.3 watts will be dissipated. The 75s is marginal as well. I suggest you use 4 56 volts and 127 volts to make the string out of 1 watt devices, or uprate the power rating on the devices I was using. And he's actually right. This schematic that we borrowed from Triode Dick actually just called for 250 volts of stacked Zeners. It didn't tell you exactly how to get to that, and it said all at 1 watt. And what I happened to have on hand were some 75 volt Zeners and some 100 volt Zeners. So I was going to stack a single 100 and two 75s, which would have gotten me to a total of 250 on each side of the amplifier. And what this guy's recommending is, hey, let's stack 4 56s and 127 on each side. So 4 56s and 127s, 251 volts. It's close enough. And I just wanted to point out, I've had a lot of people ask me for the BOM and the schematic up front before I finish this series. And I'm saying here, this is exactly why I'm not posting the BOM until this amp is done. It's been tested, tweaked, and it's ready for prime time. When we wrap this series up, we'll post both the schematic and the BOM for everyone at that point. Okay, let's look at some just general build considerations. First thing you want to do is take your time and plan out your component layout and wiring. I've had guys that are much better at building amplifiers than myself tell me that they spend as much time planning as they actually do building, and I'm usually not quite there. I usually quick to build and quick to find mistakes and correct. So maybe a little more planning would suit me well as well. So first thing you want to do, you're going to want to wire up your power supply and heater wires first. You're going to want to keep your wires with AC voltage as far away from signal carrying wires as you possibly can, or parts. Where AC and DC must cross signal paths, try to do so at right angles and with as much separation as possible. So let's say you've got an AC wire running really close to the chassis and you've got to cross a DC path. Maybe lift that wire up 1/4 of an inch inside the chassis. So not only do you have horizontal to vertical separation, but you've got some space in between those things as well. You're going to try to keep your power supply circuitry as far from your signal circuitry as feasible. And you're going to want to use a star or bus ground system. And I just noticed I spelled bus wrong there. And a great thing to use for that is some number 10 Romex, and we'll show you that here in a minute. And I found this old EIA chassis wiring diagram from the 1950s, and what it was basically saying was, hey, all your ground wires and grounding elements return should be black. You should wire up your heater filament wires with brown. Your power supply B+ should be red. Your screen grid should be orange. Your cathodes yellow, so on and so forth. And I have seen amplifiers that actually use this EIA wiring scheme, but I've also seen a lot of other color schemes. So, just a general guideline if you want to follow it. If you don't, it's not that big a deal. Okay, I'm going to show you how we're going to wire up the power switch and the fusing. And this is for the USA. If you're in the UK or Europe, Australia, somewhere else, you may have to translate this. Whereas we have black wire, white wire, green wire here in the US, or green yellow wire. A lot of times in Europe you may have blue wire in there instead. So you're always going to want to fuse the hot wire, which is known as the black wire in the US. And so what you want to do, this is an IEC socket, just the backside view here that I kind of sketched out. So you're going to want to leave the black side here, or the hot wire here, with a black wire, and you're going to want to come over and you want to go into a fuse, okay? Then you're going to want to leave the fuse holder and go to the switch. So you'll leave your fuse and go to the switch. Sometimes I see people go to the switch first, then the fuse. Well, what happens if your switch happens to get shorted on the inside, or to ground or something somehow? Then you've got a dead short here before your fuse. So always fuse, then switch, then take it into your transformer, and then come out the other side of your transformer and take that all the way over to the white wire or the neutral. And then you're going to want to bring this little green and yellow wire and take it to chassis ground as close as you possibly can to the IEC connector. And a lot of people recommend making this just a separate connection of its own, and don't share that with anything else in the amplifier. All right, very important topic, heater wiring. If you kind of get your heater wiring wrong, you will have hum in your amplifier, and you will be chasing it down for a long period of time. And so if you have hum in your amplifier, one of the first places you might want to go to is your heater wiring. So just some guidelines here. You can use brown or a green wire if you want to kind of follow the color codes, or use whatever color makes you happy. Orange wire transmits electricity and current just as well as a brown wire, but if you're trying to be consistent in your color, you can kind of use those. You're going to want to twist your wires at least 6 times per foot at a minimum. The more the better. And you can see here how this one's twisted way more than 6 times a foot. You probably got 6 twists here and 5 inches or so on this example. You're going to want to use a drill to twist these if you need to get them good and tight like this. You just kind of lock down one end of your 2 wires here into a vise, and take the other 2 ends of your wire and put them into the chuck of your drill, and you slowly start turning your drill and just keep tension on it, and you will eventually tighten them up and get them like this. Recommend using 14 to 18 gauge wire for heaters. I know this is a little bit of a religious debate. I know some guys that use solid wire and they absolutely love it and wouldn't do it any other ways. And I know some other guys that use stranded wire and absolutely love it and wouldn't do it any other way. So whatever works for you there. There again, keep signal and or power wires at right angles to heaters as much as possible. Use corners and edges as much as possible. If you'll notice how they came off the tubes here, went straight over to the corner here, ran along the corner, fed it back over, came straight out, kind of tied into another tube here, and then typically you're feeding these serially, so you'd feed off of this tube to the next tube. Well, they didn't come straight across here. They came straight back out, hit that corner again, came over, came back and hit this tube, came back, and then fed back down. And I stole this picture off of a website here on DIY, or a thread on DIY Audio. If you kind of go to this link right here, it's called Heater Wiring Bad and Ugly. There are a lot of good examples on there on how to do your heater wiring, and as well as a lot of good discussion on heater wiring.
All right, let's talk about signal ground and avoiding ground loops. So I got busy making this video, and the next thing I know, I had created about 6 or 7 slides just on grounding. And I thought, wow, this is enough content for its own video. So you can see the purple box here. Go watch my video on understanding tube amplifier schematics, grounding, part 6. I pulled all that content out of this video and went and made it its own little video, but it directly applies to what we're doing here in the single-ended amplifier build. If not, here's a few tips, but there are many, many more in that video. Ground loops are one of the worst causes of noise in a tube amp. We want to avoid them at all costs. You kind of see here what ground loops are. You've got multiple, kind of circuits here. You got this circuit, you got a secondary circuit here, and the connectivity between each of these, they all feed back via this ground, and you can end up with multiple ground loops feeding. In other words, multiple ground currents flowing through a single point. And you want to try to avoid that in an audio amplifier. Easiest way to do that is leverage a single ground wire throughout the amplifier called bus grounding, and there's a lot of tips in that other video on how to do proper bus grounding, or a point, otherwise known as star grounding, and sometimes we do multiple star grounds, and there's a lot of tips on how to do that in that other video. You definitely want to isolate the input jacks from the chassis. Make sure that the outer part of the RCA jacks are not grounded to the chassis where they're mounted. Then ground those wires to the gain stage they are feeding, if you're using a multi-point star ground, or to the furthest point away from the power supply on the bus if you're using a bus ground. Isolate the output jacks from the chassis, feed them directly from the speaker output, feed those jacks directly from the output transformers. Do not take those to chassis ground. The center tap of the filament windings should go to either the first early on in the bus or the first star point. Grounding side of the very first filter capacitor and all subsequent, the power supply should go to the bus or the first star point. Bring all bias points to the bus or star point, or point on the bus, and then tie the bus or star to the chassis at a single point, not multiple. So if you run a bus wire throughout your amplifier, do not ground it on both ends. It's very, very important. And like I said, there's a lot more to learn here in this other video. These are just a few high-level tips.
Okay, I've got the thing on the bench now, and we're gonna see what we can do here. First thing I'm noticing is this thing looks like an octopus. I mean, it's got wires everywhere, so you're like, how do you deal with all this? We're going to start eliminating the wires that we don't need and kind of cutting them off and kind of shoring them up. The first thing I was looking at here is this 40-18029 transformer that we're using. Right here, we're going to wire it up for 120 volts, and the way that works is you tie the black wire together with the brown wire, and the black-white wire together with the brown-white wire, and then you don't use the gray wire or the white wire at all. So let's eliminate those two. I'm going to want to leave enough here that if I ever wanted to come back and you know, solder onto these things and use them in the future, I could. But the likelihood of me wiring this amp up for anything other than 120 is pretty low. So I'm going to cut these off like this, and then we're going to put some heat shrink tubing over them and kind of insulate them off. Okay, as you can see here, I got those two kind of tied off at this point. Up next, I'm going to get these, the red, white, and the red, green wires here are not used at all either. If you'll notice here, red, white, and red, green right here, they're kind of center taps that we're not going to end up using on this amplifier. So we'll ultimately end up using the red, and the red, yellow, which is the very middle center tap here. As you can see, I've got those tied off as well. Just the more we can get out of the way, the easier it is to work inside this amplifier. By the way, the orange here is the shield in the transformer. We're going to end up tying it off to our bus ground. And the two blue wires are actually going to end up feeding back up through the chassis. Those will end up being our plate leads for the top hats of the 807 tube, so we can just kind of feed those up like that and get them out of the way. Okay, I'm starting now to look at my filament voltages and how I'm going to route those. Okay, just taking a look at the schematic here, the 5-volt winding here, which on this this transformer, if you look at it, the 5-volt is the two yellow wires here. And they go to pins 2 and 8 of the 5U4 socket here. And then you have the 6.3 volt, and you're going to have one side and the other side here that'll go off and feed all the 6-volt filaments in this thing. With the exception of, we're going to take the center tap of this 6.3 volt winding, and we're actually going to float it. So at this point we'll not connect the center tap. We'll get to that a little later, but if you'll notice, it's the green, and the green will end up going to all the tubes, and then the green yellow here is the one we'll end up floating a little bit later. So what I've done at this point, it's a little bit hard to see here, but I've kind of round my green wires here around. Let me zoom out just a little bit. Oops.
There we go. I ran my green wires, twisted them very tight all along the way, running them down along the chassis here, and running it all the way around over here, and we've connected it here to pins 1 and 5 on the 807. And if you look at the pins 1 and 5 here are the heaters on the base of the 807. The other thing I did is I went in and then Sharpie here 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Just mark these things from the bottom so I don't get confused anywhere along the way. And then I've taken the 2 yellow wires, which are the 5-volt filament, twisted them tightly, ran them down, kind of ran them along the bottom here over and tied to pin 2 and 8 on the octal socket, which are the heaters for the. If you'll see here, pins 2 and 8 on this. So that's what we've got wired up so far. Okay, up next you'll see here that we need to wire up the 3, 6S, and 7s. And the filaments on these are always on pins 7 and 8 here. So what we've done is fed off of the tube here over, and we've picked up pins 7 and 8, and then we've jumpered across, picked up pins 7 and 8, and we've jumpered across and picked up 7 and 8. And I used some PTFE silver coated Teflon wire that's pre-twisted, and I really like this stuff for filament wires. Now I just got a jumper from here over to here, and we will have all of our filaments fed then serially across this thing. Okay, got our heater wiring all done. Kind of, ran around over here. 6.3 tied here, coming off 1 and 5, coming off pin 7 and 8, pin 7 and 8, pin 7 and 8, and then back over to 1 and 5 here. I really like the coloring. I like using this PTFE wiring. Really easy to strip as long as you use a thermal wire stripper, and just pretty easy stuff to work with. So let's see what's next. Alright, you've got the filament wiring in at this point, but I've got something that's really been bothering me, I have to tell you. And it's been these chokes. You remember I kind of ran into a situation where they didn't mount where I wanted them to. And so I was going to pull them up here and mount them. And I've just been putting a lot of thought into that. I'm pulling, 2 things I don't like about it. I'm having to pull high voltage way up here, 1 across these filament wires, and 2 up here near the preamp tubes. And it's really bugging me. I really want to get these things back here, and I want to have the whole power supply section kind of on this back end. So as you can see, I have removed the 2 bolts on each side here and taken both chokes out, and then I just put the bolts back in. So from the top side, this thing looks the same as if I had mounted them right here. Just 2 black button heads on the top. But what I've decided I want to do here is I want to try to mount these things over here at an angle like this in this corner, because they fit perfectly right here, and which would give these wires then the perfect space to run right over here into this section I'm looking for. And the good thing is you've got the whole aluminum plane in between this choke and the output transformer underneath. And so I think what I want to do is use an existing hole here, and this one I'm going to have to figure it out as I try to mount it, because there's a little bit more spread than we have available to us right here. But I think I've got an idea on how to handle that. Okay, as you can see here on these, I cut out the notch on both ends where it was just a hole in the middle, and which will allow me to mount these things pretty darn near perfectly right here on these studs. Let me zoom back out. Oops. You can kind of see mounts up just perfectly on those studs. I just need to use a little bit larger washer here to make sure that we've got good surface area and holding down those tabs on the ends. And then on top of that, we will put our K-lock washers with this, and those things will be locked in place good and sturdy. And as you can see now with these washers on here, I gave plenty enough room now. That thing is locked down there solid as can be, and I used 2 existing bolt holes at that point. So the good news is gives me plenty of room to keep the the high voltage wires here away from everything, except for these other wires that are high voltage, by the way. But at least it's not near the low signal tubes. And now I just have to figure out how I'm going to route the filament wires back over here. Okay, I'm much happier with this scenario. These two chokes back here out of the way, leaving this whole front end kind of freed up for the preamp section, and no high voltage other than what we're feeding these tubes with up here on the front end. Okay, I've been busy for about 20 minutes here doing a little wiring up. If you can see, I wired up the green wire here, or the ground here, earth ground, to this tab here, and I've soldered it to the chassis as well, so it's a short, nice little short run to a tab soldered down. I've came off the hot wire here, and I've fed it over with a wire that feeds to the to one side of the fuse here, and I've came off the other side of the fuse here, and I've fed around all the way around, and it's a little hard to see, but you might be able to. It's kind of some wire I had that was white with a red and gray stripe on it. But I've used some heat shrink tubing along the way, just to kind of keep these wires kind of bundled together here nice and neat. I've ran it over here to the switch. I've came out the other side of the switch and ran back down that wire, and I'm tying one end of that wire off right here. So if that makes sense to you, basically what we have done here, if I did get up in my book, is we've fed out of the black or hot wire into the fuse. From that we've gone to the switch. We've came back out of the switch, and now I've created a little tag point right here, and then I'm going to hook into the transformer. And all I did was use an existing lug here on the transformer, and I put a little 3-terminal strip on here, and I'm going to tie that there. And then if you come look at the schematic here, on the 120 volt one here, you have the black and the brown that tie together, and they go to, you can see the phase dots here, so you want to put those together. So I'm going to take the black and the brown wire here now and tie it down to that exact same little place right there, and we'll have pretty much half of our power supply wired up. From the white wire here, neutral, over to this other tag point here on this terminal strip, and I brought out the black, white, and gray white wire here. You see, brown white and black white, and tied them off here. So we've completed the whole circuit loop at this point. We basically have what's shown here. We've got input, we've got switch. Looks like we need to drop a 0.047 at 630 volts across the switch. We've then got the fuse, and both sides of our primary and secondary are fed. So we'll get those going here in a minute. But as you can see, we've got everything looks pretty good and clean. I've also taken the shield of the transformer and tied it here to the earth mains ground. Did some research on, some people tie them here, some people tie them to the first star ground. They say it really doesn't matter a lot because it's not really an electrical connection as much as it is a shielding connection. Okay, I've got a 473J, which is 0.047 microfarad at 630 volt polycap. This cap does not need to be anything special or high end. We're just going to go across the two lugs here of the power switch to cut out any transients. Okay, at this point we've got the little 0.047 mounted here across the power switch. And up next, because theoretically I'm done with video 13 at this point. I said I was going to wire up the filament windings as well as the power windings here. But just to get these two long, ugly things hanging out of the way here, these come off of the EdCore transformers, and if you look up the kind of the wiring diagram for them, what it will tell you is that the white is common, in other words ground here, and that the yellow is 8 ohms right here. So I'm going to go ahead and wire both of these up just because it's a short run from right here to these two jacks, and we'll have that out of the way, then it'll be nice and clean. Alright, this thing's really starting to clean up well. Just a couple wires here left on the transformer here, the plates. feeds, which guess what, are going to feed right here. So it'll be pretty close. And then we got the power supply chokes, which we got to figure out how we're going to mount that in here, along with some capacitors. And then we've got a couple other wires here we got to get to, as well as the floating point here on the filaments. But you know what? I'm really happy with how this thing's turning out. It's nice and clean and neat, and really happy with it. So hopefully you're enjoying watching what we're doing here, and hope you learned a little something. I can tell you, if I had it to do over again, I would mount these transformers, the output transformers, back a little further, and I'd leave a little room to turn these in here sideways, these chokes. And you know, I probably wouldn't have drilled these holes here to begin with, nor these two on the sides. But these two on the sides I want to be able to reuse, because I think I'm going to mount my cathode resistors up here using one of those kind of here on the side like that, so it'll work out. But having a lot of fun, and I'm home alone all weekend. My wife is gone off with my daughter to Disney, so while they're having fun, I'm building tube amps. I think we're both having fun, but we're going to try to get a whole lot done on this thing this weekend, so stay tuned. Thanks for watching, everyone.